Okay, in this problem, initially we're trying to find h. So we can use similar triangles to do this. We've got the big triangle and then the smaller triangle, which is on the bottom down here. So if we write down our ratios for the triangle and we label this one x, we know that the height will be x plus 3. And then we can write x on 4, which is the base of that triangle, is the same as x plus 3, the whole height, over 8, which is the base of that triangle. Then with rearranging, so we bring our 4 up to this side and our 8 up to the other side. We have a simple equation we can solve, expand the brackets, and then rearrange to get x is equal to 3. Now that's what x is, but we know that h is x plus 3. So we know then that h, or the total height, must be 6 meters. Now we're after volume. So the volume is going to be the large square-based pyramid minus the bottom square-based pyramid. So the big one minus the small one. And we know that the formula for a square-based pyramid is a third base times the height. So we've got the big one minus the small one, and that's our formula. Now the base is a square, so it's going to be the 8 by 8, and the height we worked out in the last question was 6. The smaller square-based pyramid on the bottom, its base is 4, so square, it's going to be 4 by 4, and its height is 3. So when we do this math, we get 112. Don't forget the units, so it's meters cubed. If you want to know how many bins, well, if one bin takes away 6 cubic meters, then we take this volume and we're going to divide it by the 6 cubic meters, which will fit in one bin. And we'll get a decimal here. So obviously, if we want to take all the rubbish away, we're going to need to round this up so that we have a total of 19 bins. Right, now the next bit is how much litres will this be? Well, we know the volume is 112 cubic metres. We also know that 1 cubic metre is 1 kilolitre or 1,000 litres. So the volume of this pool is going to be 112,000 litres. For the hard bit, obviously the pool is only half full, so we need to find out a new height. It's no longer h for the whole height. It's definitely not 6 meters. So we need to work this out. So let's start with our original equation. The volume was a third of the base times the height of the big one minus a third base times the height of the little one. Now the little one hasn't changed. So it's still a third. It's a square. So we're going to do 4 squared by 3. And that's 16. So that one hasn't changed. Now we know the volume is half of 112. So that's 56. And we know a little bit about this. We know it's a third. We know it's the base times the height. But what we don't know is what that width of that square is now. So we're going to use similar triangles again to work this out. So it's still going to be a ratio of our base over our height of the big one will be equal to the 4 over the 3 of the little one. Now when we rearrange this to get b, it's 4h over 3. Now we can substitute that back into here, so b 4h over 3, and we're going to square it because it's a square, so it's side by side. Now what we can do is we can expand this out. So we're going to have 1 times the top, so 4 squared is 16, h squared times h will be the h cubed, and 3 squared is 9. Now I'm going to move my 16 over, so starting to rearrange, and I'm going to multiply out this fraction. So I've got 16h cubed on 3 times 9, 27. I'm going to bring my 27 up, so it's divide on one side, multiply on the other side. I'm just going to write it this way, so multiplying it on this side, and I'm going to divide through by my 16 because it's times on one side, so on the other side it's divide. Then I'm going to get rid of this cube, so cube root. Now the power 1/3 would also get rid of it. And then when I'm at this point, what I'm going to do is I'm going to put all of this in a calculator. I'm going to see that the height is 4.95 meters, not meters cubed, just meters. Sorry about that. Okay, thanks for watching.